In this video, I'm going through the step-by-step process of creation a simple epicyclic gear. The epicyclic gear consists of, in that case, of one sun gear in the middle, 4 planetary gears, and 1 ring gear. In this video, I will time-lapse the first part of the process where I create spur gears. I will put link in the description to another video where I explain in details how to calculate all the angles and radiuses. So let's get started. This is our sun gear, so let's rotate it a little bit. Rename it to sun gear. And I will also put this gear into a group right away to help to organize all other gears together later. Selecting the gear, duplicate it. Distance between two centers of two gears should be equal to sum of pitch radiuses. So in my case, these two gears are identical with pitch diameter of 20 millimeters. So the radius is 10 of one gear and second gear. 10 plus 10 is 20. So I move this first planet gear by 20 millimeters to the right. Rotated the gear by 9 degrees, and this is a middle point between two T's. Now let's position 4 planet gears around the sun gear. Copying the pitch diameter of the sun gear, and we'll place it on top of the planet gear. Just make sure that the center of this diameter is exactly at the center of the gear. So the reason why we need it here is because we need to calculate the diameter of the ring gear, and the diameter of the ring gear is calculated by the radius of the sun gear plus diameter of the planet gear. Just make sure that we're using only pitch diameters. For sun gear, this is radius of the pitch circle, and for the planet gear, it's diameter of the pitch circle. This sum gives us the pitch diameter of the ring gear. So in that case, the sun gear and planet gear have exact same diameters. So the radius of the sun gear is 10 millimeters and diameter of the planet gear is 20 millimeters. This means that diameter of the ring gear is 60 millimeters. So let's give it a name. Now, as we have the diameter pitch of the ring gear, we can calculate all other diameters that we will need to properly put the T's. I'll put on the screen the calculation process. So basically, the first thing we'll need to know is how many T's we'll have. So as a reminder, the model we use equal 1. So given that the pitch diameter is calculated by m multiplied by z, where z is number of t's, then z is going to be pitch diameter divided by m. In that case, we have 60 t's. Given that the t's of the ring gear go inwards compared to regular spur gear, to calculate the tip diameter, we need to subtract pitch diameter by 2m. So in our case, 60 by 2. The tip diameter is 58 millimeters. The root diameter is going to be pitch diameter plus 2, 1.25 multiplied by m. In our case, 60 plus 5. So the root diameter is 62.5 millimeters. So now the fun part starts. I'm going to use these ring diameters and the copy of the sun gear to construct tees for the ring gear, positioning the gear in a way that the tip ends at the tip diameter of the ring gear, and we'll use the root diameter to cut the twos from the copy of sun gear here. So like that, we're going to have exact same tees as we have on sun and planet gears. Okay, deleting everything I don't need. I'm going to hide some shapes we don't need right now. And we'll make a copy of the ring diameter, ring root diameter, and I will use it as a construction curve. I'm going to rotate these twos around the center, but I only need one copy. So this is going to be 2 times around 360 degrees divided by 60 t's. As we calculated, we'll have 60 t's. So now we can trim all parts we don't need. Join these curves and use radial array to copy them 60 times. Join all these curves. And we have our internal t's. Giving this curve meaningful name, temporarily hide what we don't need right now. So now I'm going to create an outer shape of the ring gear. Just will add maybe 5 millimeters to the root diameter, giving this diameter meaningful name. And let's see what kind of shape we have. Looks pretty nice. Let's unhide all gears so we can see what we have. Looks pretty cool so far. Now we can extrude these faces. Let's say by 10 millimeters, doesn't really matter at this moment. Hide all the curves for better visibility and as well as X-ray. So here is our result.